Alrighty, hello everyone. So in this video, we'll be covering how to route traces in the Allegro PCB Editor environment. And what I mean by route is basically to draw copper traces from point to point. So on the canvas here, you can see that there are a number of these purple traces that are already visible. So these have been routed, and what's remaining is essentially what I can see when I turn on my rat's nest. So from these two BGA packages, I see these yellow wires. I still have yet to form these connections, and we'll be doing that in this session. These squares that you'll note, these are essentially power or ground nets, which essentially just means that we need to form that connection, but it doesn't necessarily explicitly define from which pin to where it needs to be formed. It's an incomplete connection that is yet to be fully connected. Okay, so let's go ahead and get started. If I zoom into my area of interest, I see I have about 8 pins here that are showing to be unconnected. And they're actually differential signals, so you can tell by the naming convention, right? We have the positive polarity and negative polarity. These would be set up in your netlist or in the constraint manager tool. That's a separate session that we'll discuss. But for the time being, let's go ahead and start actually placing some copper traces on the board. So first and foremost, we want to expand these signals out so we can break them out and actually route in one of our internal planes. And a very convenient way to do that is actually by generating a fan out. So quite a handy feature here. So we'll go create fan out, check under the options pane, and set up the definitions for how we want this tool to create the fan out for us. So let's use a default via that we've defined, which is a through hole. And then the direction, let's actually do it on a pin by pin basis. And in this case, let's break out pointing northwest. Okay, and then now in my find filter, let's do it individually pin by pin. And so as I hover over this and click, you can see a single trace and a via has been dropped, and a very convenient method there. And I can actually just do the other remaining ones as well, and you'll see the rat's nest also shifts accordingly. So if I'm satisfied with that, right click, done. And now let's actually jump into our internal plane where we want to complete the routing. So I'm in my inner one, and now I use this add connect function. And once again, in the options pane, I see a number of other items that I can select. Let's keep things as default, but this is where you would modify your line lock, right? So at what angle the signals or the traces should change at, right? 90 degrees, 40 degrees, arcs, and so forth, and then also the width. So let's leave it as it is and actually just begin our routing process. So right now you can see that it's actually picking up just one of my traces in the differential pair, and that's because I seem to have my single trace mode selected. So to unselect it, I would just click it again, and then now you can see I have the differentials being routed together. So let's zoom out, and essentially at the location where I want the trace to make a turn, I would just click and then rotate in the direction that I wish to proceed. So continue on here. And as we're approaching our destination, I've already done the breakout pattern. So my vias are already existing in the internal plane, and it's just a simple completion by connecting it to one of those vias, and there you go. That is complete, and the rat's nest disappears for this particular signal. Now, routing is more of an art rather than a science, so there's really no procedures one can follow to have a complete, effectively routed board. It's a bit of an iterative process, and many times you'll actually have to move some of these traces around. So a quick and easy way to do that is by using the slide feature. And you'll note that once it's activated, I have a number of options that I can tweak in my options pane here. Let's keep it at default, or rather, let's confirm that our bubble is set to be as shove preferred, which means that when I select one of these traces and I try and move it, all of the other ones get nudged along, right? So that's what the shove essentially describes. The other mechanism is to do a hug only or hug preferred. What that means is it will not shift any of your other neighboring traces, right? So you will only be able to slide the selected one to a certain degree. But a very convenient a feature that allows you to quickly make minor adjustments here and there. And in some cases, you'll want to actually modify the trace itself, but you don't want to reroute it from start to end. So in that case, you can simply turn on this Add Connect feature again, and in the options pane, make sure to select Replace Etch, such that if you pick up a new starting point of a trace and have a new endpoint, it will simply just delete that previous etch and only the new one will remain. So a handy feature and hopefully one that you'll actually take advantage of. So that's all as a quick introduction on routing traces, and we'll continue to dig deeper on the other various features within the Allegro PCB editor environment.